In the last video, multi-core programming was demonstrated on the Pi Pico using the multi-core function in the Pi Pico SDK. So we had the main function for our program that runs on core 0 that has a loop that blinks one LED, the built-in LED on the board. And then we use the multi-core launch function to launch another function on the second core on the Pi Pico, which runs this blink2 function that blinks a second LED. And this works, but in some cases you might want to run even more than two processes. So here we're running our main process and then a second process on the second core. But you might want to run more than two processes. For something like this, we can use the FreeRTOS open source real-time operating system, where it will use SMP for the two cores on the Pi Pico, and you can schedule tasks to run to where the processes that you run are tasks, and then the operating system itself will handle scheduling of those tasks across the cores. To demonstrate this, we'll add a third LED off of GPIO 16 and use a third process to blink that LED using the FreeRTOS operating system. So to start off, let's go ahead and get the libraries for FreeRTOS. So we need to load the FreeRTOS source code from GitHub. So we can clone the FreeRTOS project. Where are we? So github.com FreeRTOS kernel. Note down the project. And then let's go ahead and add an LED to GPIO 16, which will be this pin on the end here. So we just put an LED in our circuit board, and we use about a 300 ohm resistor to ground as a current limit. Okay, and the kernel source code is finished downloading. The default branch for FreeRTOS is for single core usage. To get multi-core usage SMP, we need to go into the project and we need to check out the SMP branch. And there we go. Okay, so now we'll go ahead and create our project. So make a directory where we'll put this. We're going to use the same naming convention, but in this case, our FreeRTOS. And then we can go into our Pi Pico directory, FreeRTOS. And similar to all the other projects, we'll need a CMake file. We will also need our source code for the blink program, and then the FreeRTOS kernel will need a configuration file named FreeRTOS config.h. That will hold the configuration settings for the FreeRTOS library. So let's start off with our CMake file in our new project. Okay, so we're going to start off, let's go ahead and set a minimum required version for CMake. Version 2.12. And similar to what we did in the last one, we're actually going to set some variables inside CMake based off of the environment variables that we will set in our terminal. So we still need the Pico SDK path, and we're going to pull that from the environment variable of the same name. And now for the FreeRTOS kernel, we will also need a variable, and same thing, we're going to pull it from the environment variable, although that's not going to work. FreeRTOS. Okay, and we will need to pull in the CMake macro from the SDK, the Pi Pico SDK. This is basically the same thing that we did in the last project. So I will pull in the macro for Pi Pico SDK, and then there's also a CMake file for FreeRTOS, and we need to make sure we pull in the configuration file for our specific hardware, our Pi 2040, which is the microcontroller, the Pi Pico microcontroller. RTOS kernel core.cmake. So it'll pull in that macro. And our project is Blink. And let's set our versions for C. We want to use 2011 standard, and also for CMake C++ standard, we're going to use 2017. We will now initialize the Pi Pico SDK in that macro. Okay, and here we're going to add a library, the FreeRTOS library. Going to do static linking, and here we just put the paths. So the kernel path itself, and then in addition we need to specify the port for the Pi Pico third party C Raspberry Pi 2040 microcontroller port C. Port C. Okay, and then for our include libraries, target include directories. So when we compile FreeRTOS, we can do public, and we're going to use the directory that we're in, which is actually where the configuration file will be located, the FreeRTOS config header file. And then we'll also need the include path for the FreeRTOS kernel, and also we will need the ported includes for third-party GCC Raspberry Pi 2040 microcontroller include. Okay. And then target the libraries. We're going to link target libraries for FreeRTOS. FreeRTOS kernel. Oops. Don't help. FreeRTOS kernel. And for the memory heap, we are going to use heap 3. And then we still need the standard library for the Pi Pico itself, Pico SDK. Okay, and then we need to add our executable, which is blink from blink C, and then the outputs for the Pico SDK blink project and linking of everything together. Target link libraries for blink will be the Pico standard library, and we'll also link in the FreeRTOS library that we're going to compile. Okay, that should be our CMake file. Let's go ahead and do our C code. So we are going to need to include the FreeRTOS headers, and we're going to include task header, which is the FreeRTOS task library, and then of course we need Pico standard library, and then we'll do some defines just for some variables. So this is similar to the other link programs. So pin 25, GPIO 25 is the LED on the board itself, and for LED 2 we already had a LED hooked up to GPIO 15, and we just added a third LED on GPIO 16. Okay, and now let's create a function. This will be our task, so we're going to blink, and this will just run continuously. So this task we want to just run constantly. So we want to do a GPIO put on the LED pin, and we will turn it off at first. Then we are going to sleep for 2 seconds, 2000 milliseconds, GPIO put, and then we will turn the LED back on, sleep another 2 seconds, and this is basically what the other program is doing. So this will blink the built-in LED on GPIO 25, off for 2 seconds, on for 2 seconds. Now let's create another method. This will be to blink our second LED, and same routine. We're going to loop forever. GPIO, put second LED, turn it off, sleep. We're going to again blink this one faster. We'll go ahead and blink this. We'll turn off for 200 milliseconds. Turn the LED back on, and then sleep for another 200 milliseconds, and then loop. So just off and on, 200 milliseconds. And now we need our third task, blink 3. It's just the same routine over again, except this task is going to turn off third LED, sleep, and we'll make this one even faster, 100 milliseconds. GPIO put P3, turn the LED back on, sleep, 100 milliseconds. Okay, so those are going to be our 3 tasks. So before we had our main function that runs on the core 0, and then we had a function that was used as a task to run on the second core. In this case, we're actually just going to create 3 functions. Each one will be its own task, and then we'll let FreeRTOS manage the scheduling of those. So we still need our main function that will set everything up. So we've got main. First thing we do is initialize standard I/O for the Pi Pico, and now we will initialize our GPIOs. So we've got one on pin 25, LED, and it's GPIO, and we want to set the direction to GPIO out, and then we're just going to do the same thing for the other GPIOs. Set GPIO LED 2, and then set the direction for 2 to out, and then we need to initialize the third GPIO, 3. Set the direction. This is also obviously an output. Okay, our GPIO settings are all configured, and now we need to create the actual tasks in FreeRTOS. So say creating a task. This will be tied to the blink function for the first one, and we can then name this. This is LED task 1, and we're going to set a stack size of 256 words. You'll have to look into the documentation for FreeRTOS. The size of the stack that you'll want depends on what your methods are doing. You'll need some space for the context switching that is done by RTOS, and then depending on what variables you're using inside your task, you may need to make this larger. 256 is probably the minimum size that you would want. Then we're not going to pass any arguments to the task, so we'll just set this as null, priority as 1, and then if you wanted to have a pointer to the task, you would put the variable here for the pointer, but we don't need to reference the task. We're just going to let it run, so we don't need a handler. So that's for the first task. We just need to do that for the other two tasks. So we've got blink 2, blink 3. This will be doing LED task 2. This is LED 3. So this will create the 3 tasks. They're not running yet or anything. They're just created in RTOS. And so to start the scheduler, we just call the task start scheduler. And at this point, it should start running the 3 tasks, scheduling them. And this method theoretically will not return. It will just run the scheduler infinitely. But we'll just put here, just in case, just to keep it from running away. Okay, so there's our C code. The last thing is the configuration of FreeRTOS. This can get a bit complicated, and so I've actually just copied settings from another project. Shout out to the GHub coder on GitHub. He's got a project, a simple project where he demonstrates basically the same thing that we're showing here. And so I borrowed his settings for FreeRTOS. Some of these are specific to FreeRTOS, and then some of these settings are specific to the Raspberry Pi. So you can see here, yeah, so for SMP we need to define the Pi Pico has 2 cores on it, has some settings there, and then again other things that are specific to our project. And that should theoretically be everything we need to go. Okay, so we can do our build now. So let's create our build directory. Go into our build directory, cmake ... and oh, that's not good. Oh, cmake minimum would help if that was spelled right. So let's go in and fix this. Minimum. And actually, there's also Here, these should be curly braces. Same thing here to pull the environment variable. Okay, save. Let's try this again. Make sure we have a clean directory. Okay, CMake, try again, ... Okay, we should have everything configured now. Let me just say make, and this will go through and again build the Pi Pico library as needed, the Pico SDK library, FreeRTOS, and then our Blink code. Once that's complete, we can copy that to the device. Okay, there we go. Build, no errors. So right now, we're blinking just off the GPIO 25, the built-in one. The previous LED we had for the multi-core project on GPIO 15. And we added an LED to GPIO 16. So theoretically, if we do our reset, boot select. Okay, we are now mounted, so we can copy our Blink UF2 file to the mounted Raspberry Pi. And there we go. So we're now running FreeRTOS on the Pi Pico, and it's running 3 tasks. One task is blinking the GPIO, the LED on GPIO 25, on for 2 seconds, off for 2 seconds. We have a second task that is blinking our LED that is attached to GPIO 15, and that's on for 200 milliseconds, off for 200 milliseconds. And then we just added an LED here, and we are running a third task that holds GPIO 16 on for 100 milliseconds and off for 100 milliseconds. And that's basically it. So 3 processes, multi-core SMP processing using FreeRTOS.